In the second part, I solved some problems about continuity and the limits of functions for the midterm exam. In the first question, a piecewise function is given, and the question is that find the values of m and n such that the given piecewise function is continuous everywhere. The critical point in this piecewise function is 1. So when we talk about continuity, as you remember, we have three conditions. For this question, f of 1 must exist. Limit when you approach from right and left, of course to the point 1, must exist. And this limit value must be equal to f of 1. Let's go step by step. The first condition, f of 1 is equal to 5. The second condition, the limit problem. When you approach from left to the point 1, the function is mx plus n. So when x is smaller than 1, it means you approach from left. Is equal to limit x tends to 1 from right. When you tends to 1, when you approach to the point 1 from right, then the function becomes x squared plus m. Okay, we have this equality. Let's go further. Plug the number 1 here, then you have m plus n is equal to, plug the number 1 here, you have 1 plus m. This equality implies n is equal to 1. Okay? When you make first and third conditions equal to each other, it means, let's say 5 is equal to m plus n, or m plus 1, since n is 1. In this case, m is equal to 4. So, when m is 4, n is 1, the given piecewise function is continuous everywhere. It is done. Now let's look at the second example. It's similar. So it means you will have a problem like this in the midterm exam, and it's a very famous continuity problem. Find the values of a and b such that the given, again, piecewise function is continuous everywhere. Here the critical point is 0. We know the conditions of continuity. Let's go step by step. The first condition, f of 0, from the question, f of 0 is equal to, since a and b are unknown and we don't have x when x is 0, okay, since x is 0, it's not possible to have x, 2a plus 3b minus 4, it is f of 0. The second condition, limit condition, limit when x tends to 0 from left, the function is a cos x, a cosine x plus b sine x. Okay, let's plug the value 0 here. You have cosine 0, which is 1, so a times 1 is a, plus sine 0 is 0, b times 0 is 0, then you have only a. So it's from left. What about from right? When x tends to 0 from right, the function is this: a e to the power x plus 2a plus bx minus 2b plus 1 is equal to, when x tends to 0, this becomes 1, okay, this becomes 0. So you have a plus 2a plus 0 minus 2b plus 1. Let's make these two expressions equal to each other. Then you have a is equal to 3a minus 2b plus 1. Okay, so we have this equality, and this equality, it means we have 2a, let's say 2b minus 2a is equal to 1. Okay, so b minus a is equal to 1 over 2 from here. And since f of 0 is 2a plus 3b minus 4, okay, this value must be equal to the limit value, this or this, doesn't matter. Okay, so let me change the color. 2a plus 3b minus 4 is equal to, let's say, a. Okay, in this case we have, if we rearrange this equality, we have a plus, as you see, 3b minus 4 is equal to 0, so a plus 3b is equal to 4. So we have two equations to solve. Let me write down here. The first one is a plus 3b is equal to 4, and the second one, b minus a is equal to 1 over 2. If we solve this system of equality, maybe from the information high school, b is 9 over 8 and a is 5 over 8. Okay, if you have any question about this problem, please let me know, write your comments below. So it is all. If a is 5 over 8, b is 9 over 8, then the given piecewise function is continuous everywhere. It is done. The third question is the limit questions. We have 4 limit questions. The first one, when x tends to infinity, arctangent x over x. So when x tends to infinity, of course denominator tends to infinity. What about numerator? What about numerator? You either remember the graph of arctangent x or use this identity. Y, let's say y is equal to arctangent x. Okay, in this case x is equal to tangent y, right? Tangent y. So what do we have for this equality? Left hand side tends to infinity. We know this from the question. So for which value of y, tangent function goes to infinity? It is a question, right? It is a nice, it's not difficult, but nice question. For which value of y, tangent goes to infinity? If you remember the graph of tangent, this is graph of tangent x. We have these asymptotes. This is pi over 2. This is minus pi over 2. Okay. And let me continue. And it is the graph of tangent function. As you see in this graph, when x tends to, what was the question? For which value of y tangent goes to infinity? For pi over 2, when y tends to pi over 2, okay, tangent function goes to infinity, right? So the answer is, in numerator we have a number which is pi over 2. Numerator goes to pi over 2. Denominator goes to infinity. So the answer is 0. Maybe it's difficult, but nice question. Okay, it is the solution of first one. What about the solution of second one? We have ln function. Let me change the pen. Now I am solving this one. Limit x tends to infinity. We have ln function. When x tends to infinity, this part tends to infinity, this part tends to infinity. So we have infinity minus infinity case. Okay? If you wish, apply L'Hopital's rule. If you do not wish, solve using some other techniques. I want to solve without using L'Hopital's rule. I will use properties of logarithm. This expression is equal to ln x squared plus 1 over x squared minus e is a number, of course. Okay, so using the properties of limit, I can take limit to the inside of the parenthesis. Then I have x squared plus 1 x squared over e minus 1. Okay, this is equal to, when x tends to infinity, numerator tends to infinity, denominator tends to infinity. So we have infinity over infinity case. Now I want to apply L'Hopital's rule. If you apply L'Hopital's rule, you have ln. If you apply L'Hopital's rule once, then you have 2x in numerator, 2x over e in denominator. If you apply twice, then you have 2 in numerator, 2 over e in denominator. In this case, what do you have? You have 1 actually. Okay, what do we have? Let me show you. Let's first apply once. ln of 2x divided by 2x over e. Okay, then if you cancel these two terms, you don't have to apply twice. What do we have? We have ln e, which is 1. So the answer is 1. I continue to solve the other one, this problem. When x goes to 2, denominator goes to 0, and numerator, let's substitute. We have 4 minus 3 is 1, square root of 1 is 1 here, 1 minus 2. It seems we have a number, right? So I think your answer is a number over 0 is what? Infinity. Number over 0. If numerator goes to a number, denominator goes to 0, then the answer is infinity, you may say. Even if the answer is infinity, the limit does not exist. Okay? But let me solve this question approaching to the points 2 from left and from right. And you will see when we approach from right and left, we have two different expressions. Limit when x tends to 2 from left, square root of x squared minus 3 minus x divided by x minus 2. Okay. When you approach to the point 2 from left, okay, so you approach from left, sorry, not right, left. So you have numbers smaller than 2, right? You have numbers smaller than 2. So you will have negative values in denominator, right? You have, even if denominator goes to 0, you will have negative values when you approach to 0. And numerator tends to number over, of course, goes to 0, but you always have negative values. This is why the answer is minus infinity. Okay. When you approach from right, you always have positive numbers in denominator, and numerator goes to a number, no problem. Denominator goes to 0, no problem, but you always have positive values. So when you approach from right, the answer is infinity. When you approach from left, the answer is minus infinity. Still, the final answer is the limit does not exist. So it is also done. And the final one, when x tends to pi over 2 from right, what is the answer of x over cosine x? Let me remind you the graph of cosine function is the point pi over 2. Okay, so we have something like this, right? It's the graph of cosine function. So when you approach to the point pi over 2 from right, what do you see? You approach 0, right? You approach 0. And numerator goes to pi over 2. Finally, you have plus infinity here. So it is all. Not a difficult one. And the final question is the most difficult one. We will be careful about the final one. When x tends to infinity, when x goes to 0, denominator goes to 0. So we have very complicated function, right? Very complicated. So when we approach, let me first substitute this expression, the given function. I want to substitute the given function. Let's have x times square root of, let me write x times square root of x as x to the power 3 over 2. Okay, x times square root of x. Let me clear this part. I rearrange the question. Let me write limit here. X goes to 0. So it is the question, right? So when x goes to infinity 0, denominator goes to 0. Denominator goes to 0. And numerator also goes to 0. Okay. So we have an indeterminate form actually. When we apply L'Hopital's rule, we see that we have a here. We have a big expression, a times. I apply L'Hopital's rule, a is a number, so it's not a variable or function. Derivative of arctangent square root of x over a is equal to derivative of this expression, okay, with respect to x over 1 plus square of this expression. So we have x over a square minus b times derivative of this expression over 1 plus square of the same expression, x over b square. And you have limit, of course, x tends to 0. So what about denominator? You have 3 over 2 times x to the power 1 over 2. You apply L'Hopital's rule to the denominator also. So let's continue. When x tends to 0, let me first arrange numerator. Okay. If you arrange numerator, you have, it's a very complicated expression, I know, and the question is not so easy. No problem. We have a times, I take derivative of this expression, 1 over a times 1 over 2, it is coming from derivative of square root of x, 1 over square root of x, minus the same thing here, b times 1 over b times 1 over 2 square root of x. Okay, and in denominator we have the same thing, 2 over 3 x to the power 1 over 2. So you can cancel these terms and you have limit x goes to 0. Let's see what do we have. 1 over actually we did a mistake here. We forgot this expression. We forget these expressions. Okay. So let me clear this part. And this is divided by a square plus x over a square minus b times 1 over b times 1 over 2 squared x. The same thing here, b square plus x divided by b square. Okay, we have this expression. So let's continue. If you rearrange all these expressions, you have the parentheses of a square, x plus b square, minus b square, x plus a square. Okay. Of course, you make denominators equal to each other. 2 square root of x, x plus a square, x plus b square. Okay. 2 over 3, we have the same thing here. Square root of x. I didn't apply L'Hopital's rule again. I only rearranged this expression. Okay. So when x tends to 0, before taking the limit, let's continue to substitute this expression again. I continue to substitute. When x tends to 0, what do you have? You have a square x, a square b square. A square x, a square b square, minus b square x, minus b square a square. What do we have in denominator? 2 times square root of x, right? X plus a square, x plus b square times 2 over 3 square root of x. So you cancel these two terms, okay, and you cancel these two terms. Let's continue. Limit x tends to 0. What do we have left? A square x, this one, minus b square x, that one, divided by square root of x. Square root of x becomes x, times x plus a square times x plus b square, okay, times 3. You also can cancel this all x's. Here finally you have, when x tends to 0, this goes to 0, also this one goes to 0. Finally you have a square minus b square in numerator. In denominator you have 3, as you see, a square times b square. Very difficult question. Okay. What should I say about this problem? It's not so easy. And how do you get this step? I also want to say something about this. You substitute all this numerator complicated expression, you make denominators equal to each other, then you get this one. I continue to prepare other kinds of questions for the midterm exam.